So let's start with the rapid fire round. First one is, at what age do you want to retire?
65.
How long does it take you to get ready in the mornings?
10 minutes.
Most embarrassing moment of your life?
When we received our first child.
Favorite color?
Favorite blue.
What time of day are you most inspired?
Usually in the mornings.
How many hours of sleep can you survive on?
8.
Fill in the blank. An upcoming technology trend is blank.
Is AI and robots.
The city in which the best kiss of your life happened.
Pass.
Pick one, Mark Zuckerberg or Elon Musk.
Elon Musk.
The biggest mistake of your career.
I did many of them, but I don't regret them.
How do you relax?
By doing sports.
How many cups of coffee do you drink per day?
About 4.
A habit of yours that you hate.
I'm very often very nervous.
Yeah. The most valuable skill you've learned in life.
To be honest.
Your favorite Netflix show.
We like a lot Suits.
All right, well, that was the end of the rapid fire. Moving on to the longer questions, which you can answer with as much ease and time as you like. Okay. The first one is, can you share a bit about your background and how you got started in the field of artificial intelligence and reinforcement learning?
Yeah, I was always fascinated by machines autonomously doing things, also in my study, and I looked into the field of robotics. But towards the end of my study, I came across 2 favorite books, Parallel Distributed Processing by Riedmiller and McClelland, that explained all about neural networks, and it was really fascinating from the first moment. And with that, I got into machine learning and learning in neural networks. So I did my master's thesis in that field with supervised learning and a fast supervised learning algorithm. And then I moved to the even more fascinating field of reinforcement learning. So very early in my career. And with reinforcement learning, I made my PhD thesis. I then later did my postdoc on reinforcement learning in multi-agent systems. And when I got a professor, I was looking more into data-efficient reinforcement learning to make it even more practical. And then at some point, I became a professor. I was doing this more with my team. And later in my career, I was approached by DeepMind, where I finally also could do reinforcement learning at scale.
What would you say are the pivotal moments in your journey that shaped your expertise in this field?
I think very early in the career, when we did our first experiments and we saw the connection between reinforcement learning and dynamic programming, and that there's actually a very nice optimization paradigm behind that, and that it is grounded in some mathematical concepts. I was really fascinated, and I thought this might actually take us a very long way. So this was one of the moments, and another big moment was when we finally came up with a very data efficient reinforcement learning method, NFQ, and this actually works on a real device from scratch. So without going the sim to real route, but being so data efficient that you actually could learn on the real device. So these, I think, were probably the most inspiring and exciting moments in my research career.
So DeepMind is known for its groundbreaking work on AI. Could you give us an overview of some of the most exciting projects or developments you've been involved in your time there?
Yeah, the very first project was the Atari project. And that's where I still was part-time at the university. And I was very much fascinated by the ambition from the very first moment. So at the university, we were also tackling a couple of video games, but partitioning the problem in first going from perception to a latent representation, and then from a latent representation to the control. And at DeepMind, there was immediately the idea, no, let's do it end to end. And let's not only solve one game, but let's solve 50 games at once and in a very short amount of time. So this was a very fascinating project. And then when we started the robots, we did the learning by playing work, where we could show that by robots playing around, they could by themselves learn very data efficiently, highly complex behaviors. So this was also a very good moment. And then, of course, when we entered the fusion work to make reinforcement learning actually applied to a real fusion reactor, that was something with a really high risk, because there was also an external partner involved with a lot of experts. So nobody had all the knowledge at any point in time, but really it was a big teamwork project. And to get this to a success and to a Nature publication, this was also a very big moment in my career at DeepMind. And so what were the biggest challenges while doing these projects? Are there any memorable obstacles that you faced? Yeah, the challenges are always the scale. That software, writing software is not so easy anymore. So I used to write a lot of code by myself when I was at the university, and always tried to keep simple. When you do things at scales, these simple things often do not work. And so you also have a lot of technical things that you have to solve and resolve. Also, of course, as always, bringing a lot of people together with different backgrounds and with different ambitions, with different styles of working. That is always a challenge in all the projects I've encountered so far. But on the other side, all these things that are challenging are at the end also rewarding, because you're doing things that are not possible in another location or with other people or in a smaller scale.
So reinforcement learning is a fascinating area within AI. Could you explain it in very simple terms for our listeners who might not be familiar with the concept?
Yeah, probably the simplest way of doing learning is learning by examples, where a teacher provides you all the examples. Reinforcement learning takes this away and asks the learning system to learn the policy, the way it behaves completely by itself. So it's only told what to achieve, but not how. So there are no examples of how to achieve it. And this is at the same time also very fascinating, because as an engineer or as an outsider, you just provide the goal, and then you see how the system slowly starts to keep up learning, and at the end probably solves a task that you were not even able to solve by yourself, just out of self-improvement. And I also have an example of that. So in my PhD thesis, I was looking at the double card pole. So that's a card system where you want to balance a pole, but these are two poles, and you want to balance both poles at the same time. And for a single pole, you can kind of imagine as a human how you do it. But for two poles, it's kind of really tricky. And at the end, the learning system figured this out and also came up with a very nice policy. First, kind of brought the second pole in a line with the first pole, and then swung up both poles at the same time. And I found this a very elegant solution, which in hindsight is kind of obvious. But for me, it wasn't the solution that I would come up immediately, but the learning system did. And I think these are exactly the moments that we are after, and that keeps our excitement in this kind of research.
So what do you think are the most promising applications of reinforcement learning in the near future, both in academia and industry?
I was always striving for bringing reinforcement learning to control systems applications, and control system is a very broad field, from controlling the temperature in a room to controlling cars, the engine in the car, to also control whole bodies like complete robots. And I think in the future, when we understand this reinforcement learning even more, then we will see more and more applications of actually very complicated robots doing also very complicated things, instead of everything being programmed, as it's currently the state of the art in industry. And I think this will be something that will unleash a lot of potential application in industry. But also, even if we go away from robots to just controllers, being able to control devices where it's very difficult to come up with a simulation because physics is not completely understood, or there are some uncertainties, or it's not clear how to come to an optimal solution. I think there's a really broad range of applications that can be unleashed if reinforcement learning actually works very data efficiently and robustly and reliably.
Are there any ethical considerations or challenges associated with implementing reinforcement learning in certain applications?
Yeah, of course. The first ethical consideration is that this is a very powerful technique. In principle, when you can a system to just the what and it just figures out by itself, there's a lot of dangers. One is you can give it the wrong goals and it goes for the wrong goals and solves a task that wouldn't be possible otherwise. And so you have a bad intention in use. But also, even if you have good intentions, then and the goal is not precisely formulated or has some holes in it, then we even see now that the system is very creative to come up with solutions that we haven't thought of. So safety is a big concern. You always usually want to have your reinforcement learning within a safety envelope, so that you make sure that no matter what the agent tries to do, the system always stays in a safe mode. But I think the more powerful this system will finally get, the more important it is also to look at the ethical sides and to be very sure that if you give a certain goal to the system, there's no way that the agent can come up with solutions that are very dangerous or ethically not adequate for humanity.
So how do you see the future of AI research evolving? And what role do you think reinforcement learning will play in shaping that future?
So I hope, of course, and I'm kind of convinced that reinforcement learning will play a very important role. A bit with the current advent of this large language models and their big success, this is kind of gone to the background. Because, of course, what we've seen in these large language models is really astonishing and unleashes a lot of applications already. However, I think if we want to understand how intelligence in humans is working, we also need to understand how humans can build up behavior from raw experience and how they can learn by themselves, and not just by being given a large corpus of language or human curated data. So I think this current trend is very important, because we see that we can actually, if we have a lot of experience, we can generalize, and we have unexpected generalization effects. So this is a very good thing that happen at scale. But then we really will go back to the way and want to understand how we can actually make sense of all the experience, how to put it into real behaviors and to beneficial behaviors. And I think there's probably no way that a human can show all the possible behaviors that are possible within a certain context. But there we need the power of reinforcement learning or similar techniques, so that the systems can really learn autonomously by themselves.
And are there any interdisciplinary areas where reinforcement learning could intersect with other AI subfields to drive innovation?
I think one prominent area is cognitive science, of course, understanding both seeing what concepts are in cognitive science and seeing what we can learn from there and bringing them to our agents to make them more efficient, or to have ideas for subcomponents of these systems. And also probably vice versa, like AI systems can help to detect new things in physics. They can help to have a lot of impact in drug design, for example, in medicine, in biology. So I really expect that when we understand AI more and more, then we will be getting used more to assistants that will help us also to make discoveries in all areas of science. And we're seeing first signs of this already. So there are quite a couple of publications out there already in different disciplines. But this will be something where AI definitely will have a huge impact in the coming years.
So you had experience both in academia and industry. So what are some of the key differences and similarities you've observed between these two environments when it comes to AI research and development?
So my kind of industrial or experience is very exclusive. Being at DeepMind from the very first moment, we were a research company with the goal of solving intelligence, and then later by joining Google, we are having a lot of potential in compute and all that. So this is a very special situation for industry. And therefore, me, the switch from academia to industry was a big improvement, basically, in all my capabilities that I had in terms of not being responsible for writing grants to hire PhD students, but just having a team of PhD students or even postdocs to do research, and not being restricted to a 3 or 5 years time plan, but being able to plan for longer times and really ambitious. So this was where a lot of the benefits that I encountered when I switched from academia to a very exclusive industrial environment. Of course, always with the idea that finally this AI will also have some benefits to humanity and will bring up tools. But on the other side, also with a research ambition and really understanding things. I think the other side is in academia, you have a lot of freedom. You can always also switch your research topic completely. And of course, at DeepMind, I wouldn't probably not be able to do some research on art or on physics. But my research area is kind of restricted to all what has to do with AI, which admittedly is very large still.
So, but how do you manage the balance between academic curiosity and practical application when working in both settings?
So for me, that is basically the field, the area where I always felt very comfortable. So I always wanted to do academic research and understanding how to build these systems with the purpose of solving a certain task. So from the very first beginning in reinforcement learning, I always had this dream that at some point these controllers that we develop will be actually in a car, for example, or will be working in an actual robot. So because that was basically driving my motivation. So I would say for me, this is a very natural setting.
So DeepMind is known for its collaborations with various organizations and industries. Can you share any interesting insights or lessons learned from these collaborations?
So the most recent and most prominent one for me is, of course, the collaboration with the Swiss Plasma Center on the fusion work that we had. And there it was really amazing because this collaboration enabled us first to have access to a real fusion reactor, which of course you cannot build so easily as a company. And on the other side also to a huge team of experts and a huge expertise with people that are also very open to encounter new methods, like for example AI. So this was a very positive experience on a very high level of expertise.
And are there any examples of a collaboration that resulted in unexpected discoveries or outcomes or anything interesting story from collaboration?
Interesting story. So yeah, I think all collaborations also that I had at the university were kind of interesting. So in my very first experience with collaboration was in the finance industry. We were very early. We used neural networks to predict dollar at that time D-Mark exchange rates, and they actually used it in a real world system. And so for me, it was always kind of we try and we just give them the prediction that we have, and we actually could get to a reasonable prediction rate for this kind of changes in the rate. But then they said, oh yeah, predictions rate are nice, but if we don't see the money, we don't believe it. Why don't we take 1 million D-Mark and just put it on that system? For me at that time, and still is, a million euro or 1 million D-Mark was a lot of money. But they were just saying, okay, this is much more convincing. And then they actually put the money, and fortunately, they also made profit of it. But this was one of an early example where I at least got a bit to know how the financial industry works and how people are thinking in different contexts.
Has there been anything more exciting since in terms of risk investment?
Yeah, so we had a lot of applications, for example, also with the automotive and industry, where we were able to train controllers that came up with policies that they only discovered very recently. So the learning system came up with a solution that was kind of surprising. And even if they had done research on that in that area for 30 or 40 years, they only discovered that kind of policy 2 or 3 years ago. So this was a moment where also the power of reinforcement learning started to shine, and where I thought, okay, there might be a path forward.
So what about the exciting trends or developments in AI and reinforcement learning that you're personally excited about? Are there any trends that you're personally excited about?
Yeah, I'm really excited about this, that we see these effects in scaling in these large models, because this is something that, if this is actually true also for more raw data, for other data than language, then this would mean that at a certain point in experience, or with a certain point of its collected experience, out of a sudden the system can do things that we never had imagined, and so there's a magic thing that pops up that we can just profit from, but we don't have to code in, and this is a very exciting development. I'm not so sure how much data we would actually need, and whether it's actually so easy, or whether there are some pieces are still missing. In fact, I'm more convinced that there are some pieces missing until we see that also in reinforcement learning. But I'm really kind of very excited about this trend of bringing large language models together with these low-level controllers, and then understanding a bit more how potentially also the intelligence acquisition in humans is working.
So the last question for you is of a personal kind. What would you be doing in your life if not this right now?
That's a very difficult question. So if I wouldn't work in that area, I would probably just read books in that area, or code a bit of myself. So I really liked coding a lot when I did it actively from a very early age on. Otherwise, I would probably just be doing music, playing music in some kind of bar. I think that would be a kind of a different career. Probably I'm not good enough for that, so I would only have a very small audience there. But at least I could imagine to have some fun in that area.